Before we actually begin this topic, I need to talk about radian measure. And all a radian is it's a different unit for measuring angles. Okay, it's what's called a circular measure. And the reason we use it mainly is it comes down to eventually calculus and some of the other formulas we end up using. It makes it easier to work with. Now, the actual radian measure you won't be tested on until the HSC course. Okay? But some of the questions that we're going to do talk about radians and give your answer in radians. So in order to do our textbook questions, we need to be able to obviously convert between degrees and radians. But coming our assessment tasks, well, that are remaining for year 11, they'll always be in degrees. So let's have a look at them. What is this radian measure? There's our conversion. This is why it's called a circular measure, because a whole circle would be 360 degrees, and we have 2 pi radians. I suppose the relationship there is the circumference of a circle. If you imagine the unit circle of radius 1, and you have the circumference is 2 pi, and a complete circle is 360 degrees. So it really is pi equals 180. But I find it easier to think about it this way because I think, a whole circle, I can match that up with circumference. And all right, 2 pi. So just like we saw with our trig earlier, there are a lot of common ones that we see a lot. It's like 30 degrees. Well, the conversion for that would be pi on 6. Remember, pi is 180. So 180 divided by 6 would be 30. So we'll see pi on 6 come up a lot. 45 degrees is pi on 4. And 60 degrees is pi on 3. Now be very careful because it is easy to mix up the 30 and the 60 because you sort of match the 6 with the 6 and the 3 with the 3. But it's actually the other way around. Remember, pi is 180 degrees. And 90 degrees is pi on 2. Then when we move into our other quadrants, the sort of ones that we'll see coming up a lot, 120 then turns out to be 2 pi on 3, 135, 3 pi on 4, 150, 5 pi on 6, and 180, as I say, is pi radians. Now when I say pi radians, I am talking about the number pi. So 3.1415925, said it wrong, 265, whoops, and so on and so on. It is actually that many radians, okay? It is a number. Okay, third quadrant, the numbers we see a lot is 210 degrees. That'll be 7 pi on 6. 225 turns out to be 5 pi on 4. 240, 4 pi on 3. 270, 3 pi on 2. And then in our final quadrant, the common ones that we see. 300 degrees, which is 5 pi on 3. 315, 7 pi on 4. 330, 11 pi on 6, and then all the way around 360 being 2 pi. So just like we see those angles in degrees appear a lot in our questions and our answers, we'll see these radian answers appear quite commonly. But of course they don't have to be one of those. So if I want to turn 67 degrees into radians, then I would multiply by pi divided by 180. Because we said pi radians is 180 degrees. Therefore, 1 degree must be pi divided by 180. So 67 multiplied by pi on 180. And if you want to work out, it turns out to be 1.1693, pi being 3.14, etc., etc. 36 degrees, again, you just multiply by pi on 180. This one simplifies nicely. That's pi on 5 radians. And if we go back the other way then, now I'd multiply by 180 on pi. The pi is cancelled. I get 22.5 degrees for pi on 8. There doesn't have to be a pi in there just because I'm using radians. Remember, pi is just the number 3.14 and so on. So 111.1 radians, I still do the same thing, multiply by 180, divide by pi, but seeing the question was a decimal approximation, I'll come up with an approximation for my answer. 6,000 365.6 degrees. So it's quite a lot. So whilst 111 doesn't seem that many, but if you think about it, one complete circle is 2 pi radians. Pi is 3.14. So a complete circle is a bit over 6 radians. So 111 radians, you've gone round quite a number of times. And so we can see in degrees that is a large amount there. That's all I really want to talk about today. It's just basically getting used to this converting in and out, and then we can start on the topic proper tomorrow.